Hello, class. Today I'm going to ask you to watch this video, this lecture, fill in some notes that you've been given. But along the way in those notes, I'm going to ask you to jump over to a Google Doc that's a part of this assignment and answer some questions just to kind of review and make sure you're understanding that you're getting the content. When you get done with the notes altogether, you have that worksheet that you're going to be working on. And so you can work with a partner on that and kind of collaborate and make sure that you understand these topics we'll be going over today. Over the last few weeks, we've learned that all matter on Earth can be identified and described by certain physical and chemical properties. These characteristics help us know what kind of matter is what. And so things like density and reactivity and combustibility that we look and we see those physical properties, simpler things like shape and size help us identify different things. But matter can also be identified by the changes that it undergoes. And so particularly those chemical changes that we're going to be interacting with and looking at over the next few weeks. And so you see that there's a chemical change that's happening here in this equation. This is actually what we call a chemical reaction. In a chemical reaction, you see those things on the left-hand side, the CH4 and the 2O2, those interact and those molecules change into a new substance. They change into something different. So a chemical reaction occurs when two or more molecules interact and the molecules change into something new. Those existing bonds are broken and created to form new molecules. And so you see an example of that in that chemical equation. We're going to be working with those quite a bit. And so you'll learn how to predict how a chemical reaction is going to happen. You'll learn how to arrange those numbers and letters so that making sure nothing gets lost, making sure that the things that form are actual molecules that can be formed that make sense. So we'll work with those quite a bit. But before we work with chemical reactions, we have to make sure that we understand the difference between a physical change and a chemical change. In the same way we need to know the difference between physical properties and chemical properties, we need to be able to identify those changes as well. So let's start by looking at physical changes. A physical change affects the physical properties of a substance. And so when a physical change happens, those particles are rearranged, but the identity or the chemical composition remains the same. And so it changes the form or the appearance of the substance, but it does not change the substance into anything new. And so you see some examples there. Whipping eggs, they're still eggs, but the form looks different. The appearance looks different. Boiling water, that phase change that happens from a liquid to a gas, but it's still water. It's still H2O. And so the physical changes occur, but it's the same chemical compound that it was before. Dissolving sugar is another example of that. Or dicing vegetables. You're changing the shape, you're changing the size, but it's still the same vegetable when you're done. Some ways that we can physically change a substance is changing the state of matter. So melting it down or freezing it or boiling it. These change the state, but it doesn't change what the substance is. Changing the color or the temperature. Now here I'm talking about intentional color changes or intentional temperature changes. You're adding heat intentionally or you're adding a different color such as food coloring. Those can happen in chemical changes as well, but it would be not the intent of what you're doing. It's not you're adding the color or the temperature. It happens kind of as a byproduct. But if you're adding it, it's a physical change. It changes in the shape of something. And so when you tear the piece of paper in half, it changes the shape of that paper, but it's still paper. Or changing the texture. If you were to go down to the tech class and grab a piece of wood and some sandpaper and begin to sand that down, you'd be changing the texture of the wood, but it would still be wood. In all of these too, you can change it back to what it was. And so if you melt an ice cube down to water, you can freeze it and change it back into an ice cube. If you were to dye your hair, you can change the color back. You can dye it back. Changing the temperature. If you're raising the temperature of something, you can lower the temperature. And so in all of those, you could change it back. Even that piece of paper, you may not be able to change it back exactly how it was, but you could get a piece of tape and tape it back together. And so those changes are reversible, if you would. The wood, you could take it and rough it back up and make it the texture how it used to be. And so before we move on to chemical changes, I want you to take a minute, go over to the Google Doc that's attached to this assignment, and go ahead and answer these 4 questions just to kind of review, make sure you got it. If you need to back the video up, you can do that. But make sure you understand what it is that we're talking about when we talk about physical changes. So I want you to go ahead, pause the video, and go over and answer those questions. All right, now that you're back, you've answered those questions, you understand what a physical change is. Let's go on and talk about chemical changes. Chemical change is something that results in the formation of a new substance. And so when a substance undergoes a chemical change, its identity and its chemical composition actually change. A chemical change occurs when 2 or more substances join together to form new substances with new chemical properties. And so some examples of this are iron rusting, gas burning, eggs cooking, and bread rising. And each of those, you can't really return it back to its original state. Something has changed, and the chemical compound is now different. This change happens because those bonds break and reform. We talked about in that chemical equation. For example, when we burnt the piece of paper, that it became something new. We can't go back and change that back into a piece of paper in the same way that we could when we just ripped it in half. It formed a new substance. Now, chemical reactions kind of are identified in 2 different ways. Chemical changes are identified 2 ways. One is exothermic reactions. These are releasing energy. Often we see these as heat and light of how this energy is released. An example of it would be a campfire, burning wood. You see energies being released in the form of the fire. And then there's endothermic reactions. Endothermic absorb energy. It requires a continuous input of energy, like baking bread. And so, as heat is continually added into the bread, then the reaction is continually taking place. It's absorbing that heat and creating something new as a part of that process. And so the question comes up, what changes can occur in a chemical change? And so let's look at some of those questions that can happen in a chemical change. First, we could get an unexpected color change. And so the unexpected is the key word here. Unexpected color change. New molecules created in the chemical reaction radiate light differently to produce new colors. And so this isn't simply adding a food coloring to something, but it's really the reaction that happens. And so fireworks would be an example of this. When those molecules react with one another, it produces a light change, leaves changing color. So we're in a time of the year where leaves are changing color all around us. That's a chemical change that's taking place. It's not that we're going in and coloring the leaves a different color or adding a dye to the leaves to change the color. We are watching that chemical process take place. Another example would be an unexpected temperature change. So during a chemical bond, energy is released or absorbed, making the surroundings hotter or cooler. Again, this isn't that you've added heat. You haven't placed anything on a burner or next to a heater. It's the chemical reaction that's causing the temperature change. That's what makes it different than a physical change. Adding salt to ice lowers its freezing point. So that's an example of a chemical change. Body temperature changes to fight infections. If you've been sick recently and you've had a fever, your body is heating up to be able to fight that infection. You haven't been sitting next to the heater necessarily when that happens, so it's not that physical interaction between your skin and a heat source. It's the internal chemical reaction that's taking place in your body. Another example would be combustion or burning, a chemical reaction between a substance, usually including oxygen, and it's accompanied by giving off heat and light. So it's a permanent change. It can't be undone. Wood burning, striking a match. These are things you can't go back and put it in its original state. They're all chemical changes. Another one is precipitates form. And so it's when a solid suddenly appears in a solution and settles to the bottom or collects on an object and it makes the solution cloudy. This is like milk souring. And so when that chemical reaction begins to take place and the milk begins to curd and those solid pieces there, if you've ever poured out old milk, you know what I'm talking about. You have the smell that's changed, and those precipitates have changed as well. You could also have bubbles that form when gas produces a chemical reaction or release. So an Alka-Seltzer tablet, dropping it in the water, shaking up a soda, and unscrewing the top. That those bubbles begin to form as a result of a chemical reaction. So I want you to go back to that Google form now and answer these 5 questions about chemical changes. So we've already looked at physical changes. You've kind of nailed down and identified what those are. Now look at chemical changes. After you've answered these, I want you to move on to that worksheet. And if your table partner there is done with their notes, you can work together. If they're not done yet, go ahead and start on it, and then you guys can compare once you're done. But really want to kind of nail down these physical and chemical changes so that we can move on and start doing chemical equations. So go ahead, tackle that worksheet, see how you do it. I'll be walking around making sure that you understand what it is you're talking about.